Welcome to video 2. Today we're going to talk about identifying types of functions. So if you'll recall, we talked about how linear functions have a common difference with a constant rate of change between each time interval. This d number represents the slope of the equation. Exponential functions have a common ratio with a different rate of change between each time interval. The R number represents the B value of the equation. Now, just as a reminder, I'm also going to write the equations above them. Linear functions, remember, the equation is y equals mx plus b, and exponential functions, the equation is y equals ab to the x power. So now we're going to start looking at some questions relating to linear and exponential functions. So this question says, we have two equipment rental companies and they have a penalty policy for returning their equipment late. The first company will, on day 1, the penalty will be $5. On day 2, the penalty is $10. On day 3, the penalty is $15, and so on, increasing by 5 each day the equipment is late. So here we have this increasing by the same amount, so it's always going to increase by 5 per day. Company 2 has a different policy. On day 1, the penalty is a penny. On day 2, the penalty is 2 cents. On day 3, the penalty is 4 cents, and so on, doubling the amount in each additional day that it is late. So now we have Jim, who rented a digger from Company 2 because he thought it had the better late return policy. The job he was doing with the digger took longer than he expected, but it did not concern him because the late penalty seemed so reasonable. When he returned the digger, it ended up being 15 days late, and he was shocked by the penalty fee. What did Jim pay to Company 2? So in order to fill this out, we need to look at our table over here so we can compare day 1, the penalty for Company 1, and then our day 1 Company 2 penalty, and go all the way up until we get to that 15th day to compare the two late fees. So I'm going to scroll down so I can see this a little better so we can see the whole table. But remember those important pieces we highlighted. Company 1 is increasing by 5 each day. Company 2 is doubling. This one's starting at $5 penalty. Company 2 is starting at a penny. So in the table, I'm going to start by putting in the 5 on day 1 for Company 1 and the 1 penny on Company 2 for day 1. So the Company 1 penalty went up by $5 per day. So that means as I keep looking here, it's going to go from 5 to 10 to 15 to 20, just increasing by 5 all the way through till I get to 15, being a $75 fee. Now, the other one is doubling. So we're going to start with a penny, then it's going to become 2 pennies. And then as we continue this pattern of doubling, we can see that it grows to big numbers as we get further down. So we have only 4 cents, 8 cents, 16, 32, 64, $1.28, $2.50, $5.12, $10.24, $20.48. These all are better than the linear when we look over here, $40.96, $81.92. At this point now, we can see that this is actually becoming more expensive. And then doubling that, instead of just adding 5 like we did on the linear function here, that became $163.84. So when it asked, since it was 15 days late, what did Jim pay to Company 2? Well, 15 days, the fee would be $163.84. What would Jim have paid to Company 1? Well, if he had borrowed it and been $15 or 15 days late, just like he was, then that would only be $75. So what type of function does the fees for Company 1 represent, and why? Well, I just talked about that. I said this is going to be a linear function, and I know that because it has that common difference. When we have that adding 5 each time, that makes it linear. So linear function because, and I can just say d equals the common difference equals 5. There was a common difference of adding 5 every time. What type of function does the fee for Company 2 represent, and why? Well, that one would be our exponential function, and the reason is because we had that common ratio. So because the R value, common ratio, is equal to 2 because we're doubling each time. So because we have that common ratio, that makes the company 2 function exponential because we're multiplying every time by the number 2. Okay, now on to question number 2 back here. We have, given the situation below, identify if it is linear or exponential or neither, and explain your reasoning. So remember, we're looking for linears to have a common difference, exponentials to have a common ratio, and if it doesn't have either of those things, then we wouldn't be able to identify if it was linear or exponential. So we're going to talk about this more together in class, but I'm going to let you try these in class where we look to see what is the pattern and what does that represent. So if I look here, I'll do the first two together. So a savings account starts off at $5,000 and receives a deposit of $825 per month. That means every month I'm adding $825. Adding that each month makes it a linear function. And that's because we have a common difference of $825, adding that $825 per month. The next one says the value of a house that starts at $150,000 and increases by 1.5% per year. Well, this is a rate. It's increasing times 1.5% every year. That percent, that makes it an exponential because it has a rate that multiplied by the 1.5% every year. So I just wrote exponential because we multiply the 1.5% each year. We're going to keep going with this. Just remember, you're looking to see, is it going to be adding the common difference to make it linear, or is it multiplying to make it a common ratio, therefore being an exponential function? If neither of those two things are happening, then it can't be linear or exponential. Okay, we'll talk about this more in class. Have a great night.